So we're going to go ahead and start talking about how to graph what's called quadratic functions. Quadratic functions are going to come up a lot this year. And when I say quadratic function, that means a function that has an x squared term, where the exponent of 2 is your highest exponent in the function. So we're going to graph them in the form ax squared plus k today. Before we do that, we're going to go ahead and just graph plain old y equals x squared. So no number in front of the x, well, there's a 1 in front of the x, and the k is 0. So y equals x squared. In order to do that, I'm going to go ahead and plug numbers into a table. So I'm going to do -2, -1, 0, 1, and 2. I'll plug those all in for x. So when I plug -2 in, I'm just doing -2 squared, which is 4. So I'm going to go ahead and plot that coordinate, -2, +4. And then -1 squared is +1. So I'm going to plot that coordinate, so -1, +1. 0 squared is just 0. So 0, 0. 1 squared is 1. And 2 squared is 4. So I'm going to plot the 2, 4. And then you just go ahead and draw it. It looks like a little U shape. It's called a parabola. That's this term right here. So we call something called the axis of symmetry. That's what divides the parabola or mirrors it. We call it the axis of symmetry because it's the line of symmetry that splits the parabola in half. Notice it's a reflection on either side. So in this case, that's the axis of symmetry. The lowest or highest point of any parabola is called the vertex, just as some terminology. And then domain of a parabola is always all real numbers. We notate that with like an R with a double line right there. While the range is dependent on the vertex. So our lowest point in this graph is 0. So we would say y is greater than or equal to 0 because the graph only goes above y is 0. There's nothing below it. Okay, so that's some terminology just so you know it. Now beyond that, we are going to talk about what the a would do to your function and what the k would do because it's going to change what the graph looks like. So all of them will still look like a u, but they might be like a stubbier u, like a shorter u, or they might be a really steep u. They might be shifted left, right, up, down, and whatever. So in order to do that, I'm going to actually switch screens really quick and show you a little app. So this is the Desmos, well, it's the website desmos.com, but you can also get it as an app. Anyway, this can show you what the different graphs should look like. So our base graph, the one that we just did, is x squared. That's highlighted here in red. I've already typed it in. So I'm going to reveal what 2x squared. So that 2 represents our a. So notice with that 2 in front, it is, if we even zoom in right here, I don't want to zoom in that much. There we go. So we've got our origin right here that I just highlighted. On the red graph, our next point coordinate is that as like a highlight is 1, 1 right here. At that same coordinate, notice it's double. It's 1, 2, if I can get it right on there, 1, 2 on this other coordinate, on this other graph. So that 2 stretched it, we call it a vertical stretch. So 5 should make it go even steeper. So notice if we compare all three graphs, it goes steeper. And if we go over 1 and then up to 5, right here, the coordinate 1, 5, that's our coordinate right here. So it's made it steeper. Now if we throw a little negative sign in front, what you'll notice is that actually will flip your graph. Okay, so a negative in front of what we call the a flips it. Now this one's going to be interesting. I'm actually going to skip this next one. I'm going to go to the 1/2 x squared. In fact, let's go ahead and delete these other ones. If I do 1/2 x squared, that is how you get a stubbier, and let me change the color for us right now so that we can see it better in contrast. So that's a little stubbier graph, what we call a compression, a vertical compression. Now, vertical compressions only happen if you are less than 1. So 3/2, if you divide 3 by 2, you get 1.5. So that still would actually create a steeper graph. But anything lower, so like 2/3 is smaller than 1, that gives us a shorter graph. Okay. So that goes to the K. So now we're going to head over to the K. What does the K do at the end? Well, that K is what shifts things up or down. So notice this +1, we moved our vertex up 1. The -3 on this one moved our vertex from 0, 0 down to 0, -3. So this one should shift down 5 if we're correct, and you'll see it's down here 0, -5, and 0, 0. Okay, so that was just to help you see, kind of explore a bit. You can explore a little bit on your own as well. But once again, the K, if we go back to this, tells us how far up or down we're going to go. And the A is what we call our vertical stretch or compression. And those are the two things you really need to know.